Okay, so what we hope to do today is talk about creating 3D maps in ArcGIS Pro, which is Esri's newest desktop GIS application. It is a fully 64-bit enabled application, which means that unlike ArcGIS for desktop, it can take full advantage of all the modern hardware that most computers now have. It can utilize as much RAM as you want to throw at it. It can use as much processing power as you can throw at it. It will take full advantage of graphics cards with graphics processors and dedicated graphics memory, and all those kind of things, which makes ArcGIS Pro a very powerful tool that's much more efficient and effective than the old-fashioned ArcMap and ArcCatalog have been. And within this new application, we can create both 2D and 3D maps that utilize all that power and really increase the capabilities of what we do within our GIS, because, let's face it, the world is becoming a more crowded place. The need to track assets, know where they're at, not just on a 2D plane, but in a 3D environment. So when somebody's going to go and lay in a new gas line, they don't actually cut through the water line, or vice versa. So we need to really start looking at things in that 3D realm. It also opens up a whole new way of visualizing data. We've always talked about the advantages of putting data down on a map because it allows us to see relationships and patterns that aren't apparent in traditional tabular format, right? So adding that 3D capability opens up another realm of visual inspection and analysis to us that the 2D plane doesn't. We can see additional relationships and things with this capability of creating 3D maps that ArcGIS Pro now brings to the table without the need of an extension. And I see some questions coming in. Feel free to ask questions. I'll try to get to them towards the end, or if they fit with what we're talking about, I'll get into those. So please feel free to ask questions. The first one came in: can ArcGIS Pro access embedded GPS on a laptop that has GPS via a broadband card? Fred, I'm not sure on that one. I've never tried it and I haven't looked into it, but I will, if you'll shoot me an email after this, I'll try to do some digging and find out on that for you. So as I said, I'm not afraid to admit I don't know something either. So, okay, good question. So we'll go on. My name is Trip Corbin. I'm the one teaching the workshop or the webinar today. I've got about 20 years of surveying, mapping, and GIS related experience. So been around and done a lot of things. I'm the CEO and co-founder of EGIS Associates. We're a GIS services company, help with GIS implementation, needs assessments, data updates, application development, training and support, integration of GIS with other business apps like permitting or work orders or zoning, those kind of things in there. I'm also the URISA president-elect, so that's the Urban and Regional Information Systems Association. Great organization. If you're not a member, I encourage you to become one. I'm also in the Southeast GITA or GITA board here in the southeastern U.S. Covers Georgia, Alabama, and Tennessee. So very excited to be part of that group. I hold multiple certifications. I've got my GISP, CFM, which is Certified Floodplain Manager, Microsoft Certified Professional, several Esri technical certifications. I was also a certified Esri trainer up until they closed the program down at the end of 2014. So I was one of those for a long time. And probably my greatest and newest accomplishment is I just published a book, Learning ArcGIS Pro through Packet Publishing. So that just hit the shelves back in December. So very excited. My first book. It was good to get that out there. Okay, so what we hope to cover in this webinar, the next 45 minutes to an hour, we'll see, is we'll talk about how do we actually create these 3D maps in ArcGIS Pro. Well, what's the process? What are some limitations? Those kind of things. We'll look at an elevation surface. How do I set my ground elevations in these 3D maps? Because it's a very important process. We'll talk about what can serve as a ground elevation in there. And then we'll look at the different methods of displaying both 2D and 3D layers in a 3D map, because you'll often need to have both. Not everything will be 3D. So we'll talk about different ways of doing that going forward. Okay. So, as I mentioned, ArcGIS Pro has the ability to create 3D maps without the need of an extension. In the days of Arc Desktop with ArcMap, ArcCatalog, we actually had to have an extension. We had to have 3D Analyst in order to produce 3D maps. And that's because 3D Analyst came with two other applications, being ArcScene and ArcGlobe. And within those two apps, we could generate these 3D scenes for seeing different 3D relationships, extrude buildings up, and all those kind of things. With Arc Pro, I no longer need that extension to create a basic 3D map. So I can create a map just like you see here in the slide without having to have that extension. Now, if I want to do 3D analysis, like do a viewshed analysis, for example, you will have to have the 3D Analyst extension, and Arc Pro does have that extension. It's one of the ones currently available with ArcGIS Pro to do that level analysis. But to produce a simple map like you see here, you don't need that. See, a question came in, can ArcGIS for desktop use a map in 2D after you create a 3D map in ArcGIS Pro? So, okay, ArcGIS Pro uses a whole different set of files than ArcMap. It uses project files, APRXs, instead of MXDs. You can import a 2D map from ArcMap into Arc Pro and then copy that and turn it into a 3D map in Arc Pro. But so no, if you create a 3D map in Arc Pro, you can't open that back up in ArcMap or even ArcScene or ArcGlobe in there. So Elisa says she's having problems with audio. Anybody else having trouble with audio? You can use the chat window to respond to that instead of the questions. Okay, looks like most people are having fine. I will say this, if you're, depending on your internet connection, if you're trying to view the, slideshow, there we go, and use the internet to listen to audio, if you don't have a strong internet connection, you may have issues. You may want to try to use the call-in function. So. Okay, so we'll go ahead and keep on. So as I said, I can create 3D maps in Arc Pro pretty easily. I'm going to go ahead and jump in here to show you one. So I'm in Arc Pro. You can see the ribbon interface that it uses. I've got the contents pane over here, which is similar to the table of contents in ArcMap, and I've got my project pane over here, which is similar to the catalog window in ArcMap. See, I've got a 3D map in here. I've got my buildings extruded. Right, I can zoom in, I can zoom out, pan around, I can set my camera angle, how high am I above the features, right? As I'm zooming in and panning around, right? So you can view, still click on features and get the information, like identify on those features, depending on what you click on within that. And you can see that I'm mixing and matching. Let me close out that information window. 2D layers. So I have my 2D, my parcels, my lakes, and whatnot is 2D, which means they're draped across my ground surface. And then my 3D layers, which are those that are being extruded above the ground. And in a single project, if I expand over here, you'll see I've got a 2D map, I've got 3D maps, so these can exist in the same project. So I can go in a single layout, and you can see this, I've combined, I've got my 3D map and my 2D map here in one single layout. Okay. So we can do this within ArcPro, again, with no extensions required. Okay. When you go to create a new 3D map, we also call these scenes. And the word, when we're talking about 3D, scene and map become interchangeable. A global scene is similar to like what you see in Google Earth when you go in and log into it, or the new Esri Arc Earth product they're coming out with. And it's going to create that globe, and it's used for large areas where you really need to see the curvature of the Earth. So here's an example of flight paths across the US, and obviously, you know, that the curvature of the Earth is going to impact those flight paths. So I'd want to use a global scene here. And in most cases with a global scene, you're going to use a geographic coordinate system, you know, whether it's WGS 84 or NAD 83 or whatever, but it's going to be that geographic coordinate system is what is normally going to be used with the global scene. Doesn't mean it has to be, but it's what it normally uses. We also have the local scene. This is good for small areas, city, county size areas that you're working with, where you're not really cared, you know, the curvature of the Earth and all that's not really going to impact what you're looking at, what you're doing. It's typically going to use a projected coordinate system like UTM or state plane coordinates, or you could even use the WGS 84 Web Mercator Auxiliary Sphere if you were going to publish this to the web, which it is possible through ArcGIS Pro with Arc Online or Portal for ArcGIS to publish 3D maps to the web to use in applications, either mobile or web-based applications, right? And so you'd want to use that auxiliary sphere or coordinate system if you were to do that. But that's going to be the first thing you have to kind of decide. Which one of these two types of scenes do you want to design your 3D map? Now you can always switch back and forth, and I'll show that to you here in just a moment on how to do that. So to create a 3D map in ArcPro, we're going to go, there's actually a couple of ways. This is one way to do it. I can go up to the Insert menu, go under New Map, choose Scene. Once I've chosen that, I'm going to choose, is it a local or a global scene? Then I'm going to start adding, go back to my Map tab and start adding layers and base maps and those kind of things. Okay, so let's demonstrate that so we can see how we do that in ArcPro. So I'm going to ArcPro, and one of the ways I can do it, I can go over here in my project pane, right click on where it says Maps. See, there's the option to add a new scene. Okay, so you can do it from there. So ArcPro is a lot like ArcMap. There's usually at least 3 or 4 different ways to do something. Or I can go up here to Insert, where it says New Map, click it, and choose New Scene. So I'm going to click that. It's going to open my new scene. And by default, it's going to use the topographic base map, unless I've changed it under my options from Esri. Wait, there we go. Okay, so it's centered based off the other maps that's in here. So this is where that came in from. And from here, I can now go to my view and say, well, if this is now, right now, this is a global scene. I can change it to a local scene. Now you can see this new scene has been created over here in my project pane. Okay. And from there I can start adding data. So I'm going to do it from the project pane. So I'm going to go here to my database, and I can begin adding layers. So I can bring in my parcels. And go ahead and, well, it would redraw, trying to pull data from Esri at the same time you're conducting online webinars, not always the smartest thing in there. So while it's doing, let me see what questions I have over here, because a couple have come in. Let's see. So can I tell you what base map is that you have your data draped over? Yeah, this is the topographic base map from Esri. That is the default one, unless you change your options. So that's coming through ArcGIS online there. Other question, what RAM amount, processor, hard disk speed, or special video card are used for this demonstration? I'm using an Asus laptop. It's actually a gaming laptop. It's got an i7 processor, 16 gigs of RAM, and a dedicated video card. I don't remember which one, but it's like a 765M, I think, video card on it. So that's, well, I mean, I actually use gaming laptops or gaming systems for most of my GIS workstations because they have the load, can handle the graphics load real easy. Yep. Another question is, ArcGIS Pro intended to be a long-term application with different functionality than desktop, or is it merely a stopgap? It is not a stopgap. It's going to be, well, this is my personal opinion. It's going to end up replacing ArcMap and ArcCatalog in probably 3 to 5 years is my best guess. It is still very much a work in progress. There's some things that it won't do just yet, but they are focusing a lot of attention. Matter of fact, 1.1.1 is the current version. 1.2 is already out in beta, and I intend to install it this afternoon. I didn't want to install it before I did the demo here, but it's supposed to have additional functionality in it, and we'll talk about that in just a minute. Can elevations be exaggerated in a base map? Yes, and I'll show some of that in just a minute. Will the presentation be available for download later? It will be posted on the EGIS Associates YouTube channel and Geospatial Training Services webpage. So yes. Okay, so we'll keep going. So now I've got this in here. You can see I can use my mouse to scroll and change my camera angles, pan and zoom in here. And I can start bringing in other layers with that. So that's the basics of creating it. Now, once I've created my basic map and added some layers in there, I need to start figuring out elevations. And there's two elevations, or at least two areas of elevation you need to concern yourself with. First is your ground. What is going to be the base or the reference that everything else gets pulled from, right? So what is your ground elevation going to be? This serves as the canvas for any 2D layers. So any 2D layers you add get draped over this canvas, okay? When you start adding 3D layers, you can say to extrude off that ground elevation, okay? So you can go up above. You can also set it to use specific elevations as well. And you can use either your own local elevation data as your ground or some sort of web source, like Esri's online ground elevation or web elevation source that is the default. And I'll show that in just a second. Once you've got your ground established, then you've got to figure out how do you show your features in 3D, if they're a 3D feature. Are you going to have it based on a field? Is there an attribute that says that's how high something is? Are you going to show everything on a single height? Do you actually have a Z coordinate collected? So a lot of times if you go out and survey data using survey grade GPS, it'll collect a Z coordinate. So you could use that. Or do you want to build some expression? So just like if you've used the field calculator in a in ArcMap, right, you can use similar types of expressions in here to extrude data. Okay. And I see those questions coming in. Like I said, I'll get to those in just a second. Okay. So to establish your ground elevation, it is a property of the map. So each map in your project can have its own separate ground elevation. So you can do that. You can actually use more than one. So here you see an example of a quarry. This was a project I worked on up in the North Georgia area around Athens, which is where UGA, University of Georgia, happens to be located. And we had a good DEM or digital elevation model of the area right around the quarry, but anything beyond that one parcel we didn't have. So I'm using two ground elevations here. I'm using a local DEM for the quarry and then supplementing that with the Esri world elevation terrain that is the standard default. So that's a web service coming in and adding that to my local. As you can see, you can prioritize them by putting them in the order. So the one at the top has priority over the one at the bottom. This allows you to expand and combine multiple elevation data sets together to generate your ground. Okay, so to set that up, go back here into Arc Pro to set my ground elevation. If I go up here to the scene, right, and go to properties, you'll see this elevation surface. So this is where you're going to be able to set that ground elevation. So I expand that out. You can see here's the default. So this is what Esri is going to use by default. So if you want to add another one, you click the Add Elevation Surface button here. Choose where your surface happens to be. So I've got a DEM here for this area. All right. And so now that can be my elevation. If this covers everything I need, I can delete the Esri one, which I'll go ahead and do. Okay. And so now it's going to use that DEM, that digital elevation model I have for my data or for my local area. Okay. And while it's redrawing that, let's see if it'll let me go back into properties. Okay. So there was a question is, can you extrude in a negative direction? And this is where that comes in. So if you want to allow navigation below the ground and extrude data below the ground, then you can check that box. So yes, you can go below the ground, David. So you can go below. Or if your data you collect is collected in an elevation that's below the ground. So if you've gone in as pipes are being collected and it's, you collect the elevation of those, right, it would be below the ground. So yes, you can do that. Okay. I can set my units here. Right now I'm using US survey feet, so different things you can control with this DEM. In there. So anyway, so you get to see that. So now I'm using this map is now overlaying everything on my DEM. Okay, as using as that ground surface elevation. Okay. Now one of the things you can do if you go, and we'll talk more about this, but there are some options here that you can go in and set. So one of the things is I'm creating a new scene, right? I can go in and choose, do I want to default to a local scene or not? So that's one of those options we can check in here as we're creating these different scenes. Let's see if they have a default. This also, we can set your custom base map. So if you don't want to use the topology or topographic base map, you can change that up here. So some of those options that are available through that. Okay. So with that, what can we use as ground elevations? What works for ground elevations? Well, I just showed you Esri's World Elevation Surface is the default, which is a web app or web-based service that comes in that you pull in from ArcGIS Online. You can also use your own, as I showed just a second ago, your own digital elevation model, a DEM, which is a raster data set. So that can be TIFFs, JPEGs, PNGs, IMGs, or raster sets that are stored in your geodatabase in there. They work really well, usually generated out of the Spatial Analyst extension for ArcGIS or ERDOS Imagine or something along those lines. You can also use a TIN, a triangulated irregular network. That's a vector-based elevation surface, and it uses a series of points and triangles to establish elevations. They're usually extremely accurate, very detailed in nature. You can get those created by various surveyors and various other applications like Civil 3D, for example. So you can get a lot of information out of a TIN. I will tell you this, for some reason, Arc Pro, at least at 1.1 and 1.0, I haven't really tried it in 1.1.1, seemed to run very slow with a TIN. Much slower than it did with using a DEM. I'm not quite sure why that is, but I did notice that. They are talking about introducing cached vector data, which might improve that performance some, but that will be at least at 1.2, which, like I said, isn't due out till February, but we'll see. So, and then other web services that get published, you could connect in as well. But most cases, you're going to use a DEM, a TIN, or the Esri elevation surface, or at least that's been my experience so far. So any of those will serve as your ground. That canvas do. So once you got your canvas, then you got to start, how do I show these 3D features? Well, I can do everything based on ground elevation, right? So what is the base? What am I coming off of? What's the ground? So it can be automatically based on the ground, or if you have a specific elevation as an attribute field or a Z coordinate, all of those can be used. And then of course to extrude or take that up higher, you've got to define the top elevation. How high does it go, or how low does it go if you're going below the ground, right? So Esri provides these 4 extrusion methods. So you got the minimum height, so that's going to extrude the value to a minimum Z value, producing a flat top. This works with lines or polygons. It does not work with points. Maximum height is going to add the maximum height to produce another flat top. Again, lines and polygons in there. Base height is going to start at whatever your base is, whether that's an attribute value or ground, and then add to it if you extrude, and then you can say an absolute height, which is the feature is actually extruded to the exact elevation. Okay, so base height could take a ground, say the ground, and then add 45 feet to it, or 30 feet, or whatever. The absolute height is going to be the exact number, right? So if you're an elevation, say around 900 feet, like I am here in Georgia, then if I have a building, I need to know that building's at 950 feet. If it's a 50-foot tall building, right? If I want to use absolute height to do that extrusion, okay? So again, to set that up, go back here into Arc Pro, and I'm going to add in a layer. We're going to add in our buildings layer, okay? And choose a different color because that's the same color as our parcels. And so that should be showing up. Yep, you can see the green parcels now showing up on top of. If I rotate a little bit, you can see that there. So when I add it, it starts out as a 2D layer. So to turn this 3D, first thing I do is drag it up and make it a 3D layer. So I'm going to drag it up to where it says 3D layers and let go. And now it's a 3D layer. Okay. Whoops. Now select it back. You can see it redrawing. Go to properties, and this is where I can set my elevation. So this is the base. Are the features on the ground, relative to the ground, or at an absolute height? So this is, I'm going to go on the ground because buildings are built on the ground, right? So I'm going to leave that in there. I could do a cartographic offset to exaggerate it. I'm not going to do that now. And my units are in US feet. If I had other elevational units, I could do that, but they're all in feet, so that's good. Okay. Now that I've done set that up, got my ground, my base elevation started, I'm going to want to extrude that. So I'm going to go up here. Notice because I have this layer selected, the feature layer contextual tab comes up, and I can click on appearance, right? And then this is where under the extrusion group here, I can choose how I'm going to extrude it. So these are those 4 different types we were just talking about. So I'm going to go with the base height because I'm coming off the ground. And then I can choose, well, how much do I want to extrude these? Well, I could extrude them all a single value, make them all 15 feet. And now all of those buildings are the same height, right? But they're now in 3D. If I open the attribute table for this layer, you'll notice I've got number of floors and estimated height as 2 fields in my attribute table. Okay. So since I have estimated height, I could actually just say extrude it based off that field, estimated height. And so now it's pulling off the field. You can see how it's, now the buildings have different heights. It's based off that. Or I could build an expression. So I click this little extrusion expression button over here and clear out that field that I'd chosen and say, well, I've got the number of floors. So that's a field. And I could multiply that by, say, the average. See, we know average ceiling height is about 8 feet. Then you got about 2 feet worth of ceiling stuff under, between floors, whatnot, joists and all that. So say by 10, right? And go OK to that. So once it finishes redrawing, it's going to have extruded each building based off the number of floors multiplied by a factor of 10. Okay, so you can choose how you want to extrude those and build all kinds of expressions just like you can. And it works not just with, that was polygons, but let's say I'm going to go down here and add light poles. And here's a 2D layer. And I'm going to bring it up as a 3D layer now. Oops. Drag it up. Come on, go up there. There we go. Okay. So this could also be extruded, right? So again, I can take it off the base height, coming off the ground, and say all my light poles are 25 feet. Okay. And now I've created that symbology, and you can still control, your symbol settings in here. If you don't like the color, you want to change the color. Make them red. You want to make it bigger in point size. Since it's a point feature, you can do that. So you can control those functions. So let's quickly look back and see if I can see some questions here. Is any questions I haven't answered? Doesn't look like any new. Would you recommend which book is good to learn spatial analysis on there? As you go through Esri Press books, there are several good ones. It depends on whether you want to know all the ins and outs of the theory behind it, or if you just want to know which tools do what. The GIS tutorials, from Esri Press, GIS tutorial 1, 2, and 3 are all really good. So Barbara says, can you make rooftops other than flat? Yes, Barbara, you can. That's a good question and kind of leads into my next topic here, my next part, which is other methods of symbolizing 3D data. Well, one of the things we can do is 3D symbols. So you can see I've got this screenshot that was actually created in ArcGIS Pro. So you can see I've got different building rooftops in here, and I've got, power poles that look like real power poles. I've got fire hydrants that look like real fire hydrants. So there are some 3D symbols in here that you can use that will give different appearances or more realistic appearances to your data. So you can create fairly realistic look. I mean, this looks pretty realistic, right? Driving through here. Also, ArcGIS Pro will integrate with City Engine. I don't know how many people are utilizing City Engine, but the symbology rules, those rule packs, RPKs, I think is what the extension they use, that you generate in City Engine, you can also bring into Arc Pro and utilize those same symbology rules to generate those, right? So it's a good question. So now let's show that. Go back here to Arc Pro again. And so first I'm going to start with these light poles. I'm going to change this. So I'm going to go back to my gallery and set to look at all styles. And let's see, do a search on light. Okay. So here's a bunch of light pole symbols. See, that's the one that my city uses here. They use this light pole symbol. Okay, so now I brought it in, but notice that it's got these, looks like tubes around it. Well, that's because I'm still extruding, so I'm going to turn off my extrusion. And let it redraw. And now I've got my light poles, and I'm going to change the size on that a little bit. Changes that. I can also set up different 3D behavior with rotation on this. I can actually go in under the properties here and control the size of my Z. So it's right now it's at 11 points. I can take it up 15 points. And it starts to do that. Now, one thing you can do, if you want to make this a set height so that it utilizes real world units. So I go to the properties of the layer, okay, and I go to display. I can set display 3D symbols in real world units. Okay. So when I make that change, notice it's no longer in points, but it's in feet. So I can say, okay, well, my lamp posts aren't 36 feet tall. They're 25 feet. And I have no idea what a light pole actually is. But now, see, that locks those lamp posts in their, their real. So the question was, are the building heights exaggerated? Some of the smaller buildings looks almost as wide as they are tall. No, they're not. They're not exaggerated. It just may be the angle that they're being looked at. Okay. So now for the buildings let me go ahead and commit the change now. So for the buildings, I can do a couple of things. One is use Esri has some procedural symbols here. That are pre-canned with ArcGIS Pro. Right. So these are, you can see they apply different at random, different faces or wraps around those buildings that give them a more realistic appearance. I can set the height again to be based on a field. And I'm not sure what kind of units that's being pulled from because it's all set up in the are you able to insert terrestrial LiDAR structures? It does support LAS files. I'm not sure about BIM. I haven't tried to bring in BIM data, but it will support LAS structures or LAS data files in there. I can go in and add other rules. So I said you can bring in, let me use here. I'm going to get rid of these. So this rule, that's the one I'm going to turn off. So let me turn on, this is the new one I just added. So I can go here and pick, so here's like Venice, okay? So this is actually created in City Engine. And you can see with this, the rules that come out of City Engine, you can add all kinds of things. So I can do the roof type is automatic. I can do a gable, a hip, a flat. So I go hip roof. I can control the roof angle because this is just what's happening here. I can set the number of floors to be a field. So there's the estimated number of floors. Okay. Now this is limiting the minimum height of a floor to 3 and the maximum to 4.5. I think this, because it's based in Venice, would be in meters. That it's basing things on, even though my data is in. Well, I downloaded this from the resource center in there. So I can actually include trees. So what's my tree density in there when I'm doing this? So all of these different rules. There we go. I'll apply that. There we go. It's going, you can see it's going kind of crazy. Number of floors, it should be using that. Yeah, no, not estimated height. Picked the wrong one. There we go. Number of floors. Helps when you pick the right field. I'll apply that now. So you can see this actually has, is part of the rules package, procedural rules. It actually has like trees, so you can show green space and things like that with it as well. It's not just the buildings, it's all part of that rules, that procedural rules package in there. You Yes and no. To make a virtual walkthrough of video, you can do what they call a roam. So if I click the Q button and move my mouse, I can do a fly through. So if you have some video recording app on your computer, you could record that. But to the best of my knowledge, I've not found a tool yet in Arc Pro that actually records that. So, but you can, like I said, if you click Q, hold your Q button down, that takes you into roaming mode, which allows you to kind of roam and fly through and those kind of things. Okay, so can I get back into here? So with ArcGIS Pro, there are some options that you need to concern yourself with if you're creating 3D maps. So this is going under the project menu and down to options. One of those is your mapper scene that I showed you earlier, where you can set either whether you want to default to a global or a local scene when you create a new 3D map. Then when you go to display, how do you want to render this? There's some options here. So this actually supports stereoscopic modes. I've never done that, but if you have 3D glasses, you can actually enable that for stereoscopic analysis in there. And how do you want to render? Do you want to use DirectX or Open Graphics Language, OpenGL in there? And other quality settings for the overall display. Obviously, the more powerful the video card, the more you can ramp those up. And then lastly, over there under units, there are, for 3D symbology, some display units. So what unit do you want to default to with setting up your 3D symbols? Do you want to use feet, US feet, international feet, kilometers, meters, whatnot as your default unit for your 3D symbols? So some of those, like I said, that's located. If you go up here to the project menu and down to options, right? So you can go through here and set. So this is the local and global that's under map and scene. Go to display. Different display options can be set here within that. And then your units are up here. So here's the 3D units that you can set here through the options for Arc Pro. Okay. And we're almost getting here to the end. I did want to let you all know that ArcGIS Pro is due out sometime, I think they're narrowing it down to February, so sometime next month, with kind of the timing it with the release of ArcGIS 10.4. Some new functionality or improved functionality. First off, it's supposed to be compatible with Windows 10. 1.1, 1.0, and 1.1.1 are not officially compatible with ArcGIS 10 for ArcGIS Pro anyway. But I'm running it here. I'm running Windows 10 right now, and it seems to work. I haven't encountered any major issues, but it's not officially compatible. Supposedly, they're also going to add data-driven pages, creating mobile map packages, charts and graphs, even additional integration with AGOL, allowing you to more easily access services published through ArcGIS Online. And then they said the ability to publish and use vector tiles, cached vector data as well, which is why I said the 10 may run better that, but that's hopefully coming in 1.2. Whether they'll add other things like topologies and geometric networks, which aren't currently supported in Arc Pro, I'm not sure. So hopefully once I install the beta version here this afternoon, I'll find out more. Question was, what is the difference between feet and US feet in units of measure? The US survey foot is slightly larger than the international foot. It like the 4th or 5th decimal place. I don't remember the exact conversion factor between those. Used to when I was land surveying a lot, I did, but I don't remember them right now. But A U.S. foot is not the same size as the international foot. Okay. Jim asked, can Arc Pro produce profiles, cross sections that can be used in a map layout? Not that I know of out of the box. Somebody may have written a Python script or a .NET add-in that would do that, Jim, but I'm not aware of any out of the box functionality that would generate plan and profile sheets yet. Good question though. Okay. If anybody would like more training on ArcGIS Pro, I do have a couple of instructor-led classes. They're happening. So next month in Atlanta, the 18th and 19th, I will be conducting a class in the Metro Atlanta area. In March, I'll be in North Carolina and Alabama doing that. Eventually, I hope once I get the bugs ironed out and Arc Pro becomes a little bit more stable and not changing so much, turn that into some online classes as well. Okay. So if anybody does have any questions, here's my contact information. Please feel free to contact me offline. I'll be happy to answer. Also, I do have my book, which you can purchase through Amazon or through Packet Publishing's website. So Learning ArcGIS Pro, which has a lot of this and other information in it. So that. Okay, guys, I'll stick around a little bit if there are any more questions, but I hope you have enjoyed the webinar, and I hope to see y'all around either at a conference, another webinar in the very near future. So y'all have a good rest of your day, and hope everybody's had a happy new year.